Welcome back. In this tutorial, we will simulate a full-wave semi-controlled rectifier using MATLAB Simulink. Problem statement: simulate a single-phase, full-wave, semi-controlled rectifier with 2 thyristors and 2 diodes. Observe the output current and voltage waveforms at different firing angles, and evaluate how variations in firing angle affect the average and RMS values of the output voltage. You can find the full course link in the video description. Before starting this tutorial, let us briefly explain why semi-controlled rectifiers are practically useful. 1. They are cheaper and simpler compared to rectifiers with 4 thyristors. 2. They are easier to trigger, as half of the commutation occurs automatically. 3. They can be slightly more energy efficient, since diodes dissipate less power. 4. They are suitable when bidirectional power flow is not required, and a simple, low-cost, energy-efficient rectifier with partial control over DC voltage is sufficient. Getting started. So, let's get started. Launch Simulink and create a new model. Save the model. Add the required blocks. Open the Simulink library browser, and then launch the standalone library browser. You can find the full course link in the video description. Open the multimeter block. First, select the AC source voltage and press the Select button. Then, choose the branch voltage, and finally, select the branch current for measurement. Open the mean block, and set the frequency to 100 Hz, as the output of a full-wave rectifier exhibits a frequency that is twice that of the source voltage. Do the same for the RMS block. Go to Simulation tab, set the simulation time to 0.08 seconds, and click Run to start the simulation. The output voltage and current are delayed by 30 degrees in each cycle, with conduction starting only after this point in both the positive and negative half cycles of the input. Also note the average and RMS values of the output voltage. Next, set the firing angle to 90 degrees and examine the results. At this angle, conduction begins only after 90 degrees in both the positive and negative half cycles of the source voltage waveform. Once again, record the average and RMS values of the output voltage. A noticeable decrease in both values can be observed as the firing angle increases. Download the model from the provided resources and test additional firing angles to observe the output. Your task: 1. Download the model, replace the pure resistive load by an RL load, and measure the average and RMS values of output voltage at different firing angles. 2. Observe how the average output voltage changes as the firing angle increases. Thank you for being with us. You can find the full course link in the video description.